Hi, my name is Paul Sullenberger. In today's video, we're going to cover 30mm crank installation on a CeramicSpeed bottom bracket. There are a number of 30mm compatible bottom bracket standards on the market, ranging from a shorter spindle to fit on a 68mm wide shell, such as a BB30 or PressFit 30 native interface, to the longer Evo 386 setup, running on an 86.5mm wide BB shell. This video will cover a SRAM Force 30mm crank designed to fit up to an 86.5mm wide frame. To do this, you're going to utilize a few spacers provided from the crank manufacturer to space out the frame on a narrower PressFit 30 or BB30 68mm wide shell. There's a unique range on a 30mm spindle designed to carry the bearing load from as narrow as 68mm all the way up to 86.5mm. This is what allows us to run an inboard bearing, such as a PressFit 30 in a 68mm platform or a BB30, and then space out the remainder of the crank, carrying the load in a lightweight, stiff, and even manner. Starting on here, with this design, we have a rotation preload adjustment, and this allows us to adjust up to 5mm of width spacing without needing to disassemble and reassemble with additional spacers. Going from this narrower width up to the wider width, we already know that we're going to need a couple additional spacers. We'll start with a 1cm spacer and apply that onto the crank. We'll put a little bit of grease on the face and a little grease on the spindle. All CeramicSpeed 30mm bearings will carry a unique chamfered dust cover. This dust cover is going to have a totally flat face with the backside having a slight raised edge that'll sit nicely against the inner race of the bearing and be free of any drag touching the seal or the outer race. Starting with our non-drive side dust cover, we can now slide the crank and spindle through. In the event that there's been a bit of surface oxidation on a 30mm spindle, it may be a little bit snug passing through. Using a soft blow hammer flat on the end of the spindle will allow that to tap through easier. Soft, even taps will get the job done nicely. Now with the crank all the way in, we'll go ahead and take a look at the amount of space remaining on the face, knowing that the crank arm is only going to sit in to the end of the spline. On this one, we have a 15mm wide spacer, and we don't want to forget our face dust cover, again with the raised edge facing towards the bearing. The spacer. Now we can go ahead and install the crank with an 8mm. This is 48 to 52 Newton meters for the installation. You always want a little bit of grease between the crank and the spindle interface to get good solid fitment. We've brought it to a proper torque. Now we'll take a look to see if there's any movement. I can feel in here that there's a little width around the spacer. And we can go ahead and with this dial adjust on the preload, we'll take this, you can use a 2mm and help tighten the load. In the event that the crank does not have a dial adjust preload adjustment, you will then remove the crank arm and add 1 to 2 spacers to take up the necessary space. Now we'll go ahead and take a little bit of that preload off as it's not spinning as smooth as we'd like. Check for any free movement. We can tighten down this preload ring. And now this crank is ready to go ride.